Today we're going to install this 1080 Ti GPU inside this Intel Mini PC. Now you may be wondering, how in the heck are you going to do that, right? This thing is a big massive behemoth, and it's got this slot here which barely is basically the size of this device here. Well, if you weren't aware, if you look on your traditional desktop motherboard, right, you're probably familiar with your PCIe slot, which this type of graphics card would slot into. Well, this is actually electrically compatible with the M.2 slot that you're usually familiar with for your NVMe SSDs. Now, this is not just for NVMe SSDs, even though it's kind of designed or optimized for it. Because it is electrically compatible, they both travel along the PCI Express lane to the CPU. So you can send basically the same data, whether it's over here or over this slot here. They're also power compatible, although the M.2 only supports 3.3 volt and up to 15 watt total power delivery out of that slot, whereas the desktop PCIe slot supports both 3.3 and 12 volt up to 75 watts total power delivery through that slot. So this particular mini PC actually has an M.2 SSD slot, and because it is basically a PCIe slot, there are actually a lot of adapters out there that allow you to do all sorts of different things so that you can hook up other devices if you'd like to. Now, they're not really mainstream, so it's something that you probably want to find on like AliExpress or eBay or something. But for example, here I have a PCIe to 6 SATA ports, or this SAS adapter, which does similar. You can convert these to SATA connectors as well with an adapter plug-in. And there's also network adapters and things like that you can plug in there as well. Now, the important thing to note, though, is this little notch here, which identifies the key of the M.2 device. So there's this is the M key, which allows up to 4x PCIe lanes to be used for performance. And each PCIe lane, a PCIe 3.0 at least, is about 1 gigabyte per second total throughput. And unfortunately, in this case, this mini PC, this M.2 slot is only PCIe 3.0 with a 1x PCIe lane. So, but for an SSD at 1 gigabyte per second or 1000 megabytes per second, that's typically more than sufficient for general purpose use. Now, in order to get from this M.2 slot to this guy here, we're going to need some sort of adapter, right? So, because like these guys, they do have adapters here. You can see here this little stick here looks very similar to an M.2 SSD. And it is keyed to M.key, which is what this slot is. The key is important because this is an M.key, which identifies what data is on what pins and what power is on what pins. So they also have like B keys, A keys, E keys. It all depends on what it's going to be used for. That's all specified on the, there are specifications for that. And some are designed for SATA ports, some are designed for wireless adapters, etc. And so you have to make sure that you get the right key for that. Well, in any case, because it is electrically compatible, it doesn't require any logic chips, so there's no chips on here at all. So basically, it can just pass the proper pins from here to the proper pins on the PCIe Express port here. Now, if I go ahead and remove this SSD, probably going to be wondering, okay, well, remove that. Well, how are you going to boot your OS? Well, thankfully, this mini PC has a 2.5-inch SATA adapter, but I'm not going to use that. Because along the same principle, this also comes with let's see if I can get this in focus here, M.2 Wi-Fi 2230 card. So this is also an M.2 slot. Now both of these are all PCIe 3.0 1x PCIe lane. So each of these is only about a 1 gigabyte per second performance out of each of these slots. Now this case, this is a Wi-Fi card, so it actually has an E key. So while most M.2 SSDs, you can see here the difference, right? So while most SSDs use the M key, you can get adapters that will convert from the E key to the M key. So in that case, I have this guy here. So I'm going to boot off of using the Wi-Fi slot, using this adapter here, and because this is a 2230 SSD, this actually has perforations on it, so you can actually break it off at the length of the SSD that you want. In this case, it has the 2230 slot here, so I'm just break it off right there, which is going to slot into here. right? Just like that. And then I can screw it down right there. Now the problem is that this guy here now will fit into here, M.2 to E-key adapter. Then I need to secure this to this here somehow. And this particular adapter does come with a washer and a screw and a nut. Problem is if you put the nut on the bottom here, it's going to touch down to the motherboard, could short it out. Even if I put a piece of electrical tape there, it's going to be propped up a little bit too much and interfere with the adapter board up here. So I ended up 3D printing a little bracket here to put on here and then just screw it down to this so we don't have that issue. Okay, just like that. So I'm going to go ahead and do that now. Oh, by the way, this is a 1 terabyte Corsair MP600 Mini 2230 NVMe SSD, and 2230 form factor has become popular because of the Steam Deck, but thankfully, and that this can slot right in here, and then go ahead and screw that down. There we go. And then I can just pop this guy on top right here. Now before I do that, I'm going to boot up the system and make sure this thing actually is going to boot up and everything. Now I have already cloned this SSD to here, so it should basically just boot into Windows like normally off of this slot here. And then we'll go ahead and hook this guy up. Now I'm actually going to test 3 different graphics cards using this adapter. One of the things that you're going to notice is because, as it noted, that because this only supports 75 watts, normally your GPU that you plug into your computer will require an additional power adapter here. And this guy will accept a ATX power supply, but it also will accept a what's called a Dell DA2 power supply here. And that's this guy right here. It's basically just a big power brick, but has a special connector on it, like that. Okay, so that'll plug in there. And this is a 12 volt 18 amp, so a little over 200 watts of power delivery. However, it does not come with an adapter for this guy right here. So you can either use a connector that goes from here, the GPU power output, to this here, as long as this is going to run off a single 8-pin adapter. I don't know yet. Or you can hook up the ATX power supply, and then that should have the proper connectors to go to this GPU. Now I'm also going to be using a 1050 Ti GPU, as well as an AMD RX 400 GPU, which I don't have on hand currently, but it should be here shortly. And going to test those in here, because both of those should be able to run within the 75 watt power delivery of that slot. Okay, I'm going to go ahead and power up this guy right now and make sure that the SSD is working, and then go from there. Okay, so I was able to boot into Windows just fine, no problem there. And I did plug the Corsair MP600 Mini 2230 SSD into both the 2280 slot as well as the 2230 slot. And you can see here in Crystal Disk Info, current mode supported is PCIe 3.0 X1. So it is limited to the PCIe 3.0 slot, X1 PCIe lane, versus its total actual potential is PCIe 4.0 X4. And here's the Crystal Disk Info for both plugged into the 2280 slot and the 2230 slot. So there is no difference there. And then I also did a quick Crystal Disk Mark benchmark here. You can see in both slots it is pretty much identical in performance. Now you're going to see here the 870 roughly megabytes per second. That's pretty much the realistic limit, I guess, on the for an SSD performance in a PCIe 3.0 1X slot. So it's not going to be able to exceed that because of that limitation. Okay, so next we're going to go ahead and just shut down here. I'm going to plug in the M.2 adapter and go from there. Plug in the GPU and see what happens. Okay, so I have the adapter connected here, no problem. It seems like there is a little bit of a, let's see if we can get close in there and see. It looks like there's a little bit of interference with that SSD and it's bowing a little bit. That shouldn't be a problem though, because there's really no circuits on this board here. It's just really just passing through from the wires here all the way up to this guy here over to there. It may just cause a little bit of increased heat on that SSD at the bottom, but for short term I'm not too concerned about that. Obviously, if this is something you want to do long term, this is really kind of more for fun, not real practical, but you could always do something like this, right? This is also a A/E key adapter to an M.2 M-key, and you could just put in something like this and attach it here. Now this isn't perforated, so you can break it off like this guy was. That was nice. But you could technically just cut this off because there's no circuits running up to here. This is just a hold down point. You could just mount it in there somewhere if you wanted to. Okay, in any case, I'm going to go ahead and boot this up and see if we can actually get the graphics card recognized. So to set this up, I'm just going to use this ATX power supply. This is the EVGA 500 GD, 500 watt gold power supply, and I'm going to use that so that way I make sure we have enough power for the 1080 Ti. All right, and then I need the 24-pin power connector here. There we go. We'll go ahead and start with the 1050 Ti. Just like that. Now I'm going to plug the HDMI port into this guy. All right, now because this is hooked up to the M.2 SSD slot, it should actually power on. The GPU should power on when this comes on. Look at that. Now let's see if we can actually boot up into Windows. It's a good sign. Actually have video output. And look at that, we're actually into Windows. We have NVIDIA GeForce 1050 Ti shown right there. And everything seems to be working. I just want to see a run of Cyberpunk and see how much it improves over the integrated graphics. Okay, this is set to low. I'm going to set this to ultra performance on the AMD Fidelity effects. That says Intel iGPU. Up there it should say 1050 Ti. I was just doing some benchmarks with the iGPU previously. And 16, 17 FPS, while it may not seem spectacular, it's better than the 7 or 8 FPS I was getting with the integrated graphics. All right, we can see that it actually worked. I'm going to actually shut down and install the 1080 Ti next just to see any type of limitations it may have. All right, it's booting up. And there we go. .1080 Ti. All right, I'm going to go ahead and try Cyberpunk with the 1080 Ti attached. Make sure the settings are the same. You can see over here it's drawing 100 watts power so far. And again, this is not Intel iGPU, it's actually the GTX 1080 Ti because that's the manual input I have to make. See here it's running at 60 FPS. Drawing 126 watts, and the fans aren't even spinning. Okay, 128 watts from the wall. All right, now I'm going to go ahead and see if I can run this without any kind of FSR or anything. Just turn this off completely, apply. All right, I'm going to go ahead and bump this up to 1080p. See the CPU pegged at 100%. 1080 Ti actually is up to high 90%, and it's drawing a lot more power now, about 217 watts. But still maintaining 60 plus FPS. Impressive. Lost about 5 FPS, but that's 1080p. Okay, I'm actually going to run a host of other benchmarks on this, both with the 1080 Ti, 1050 Ti, and the RX 6400. And I'll post a link to those. They'll be in a separate video if you want to take a look at those. Now I did run a number of tests, both on that mini PC that you saw, but also on a desktop PC with a 16X PCIe 3.0 slot. It only has an Intel i3 10100 CPU in it, but it really should give an indication of how much that X1 slot is limiting performance of that GPU. And I did test 3 GPUs, the 1050 Ti, the AMD Radeon RX 6400, and the 1080 Ti. You can see here, here's the GPUs, these screenshots from each of these. And this is the 1050 Ti and the mini PC. You can see here it's a PCIe X16 3.0 slot GPU, but it's only running at the X1 speed over 3.0 bus. And then here it is plugged into the desktop, PCIe X16 3.0, but it's running at the full 16x speed on the PCIe 3.0 bus. And here you can also see the driver version that I'm using for this. Both the 1080 Ti and the 1050 Ti were using the same driver. As far as the AMD is concerned, you can see here, for some reason it says PCIe X4 4.0, but it's only running at the X1 3.0 on the mini PC, as expected. But it says X4, which is weird because the slot itself is a full 16x slot. I do know that they probably only use 4 lanes, which is okay, but surprised that they didn't just make it a 4x slot. In any case, but it is on the desktop running at X4 and the 3.0 bus speed. And then the driver is Adrenalin 23.7.2. And then the 1080 Ti, same thing here, PCIe X16 3.0 running only at the 1x speed. And then on the desktop here, PCIe X16 3.0 running at the full speed. And then same driver that we saw before, 536.99. Lastly, the Intel integrated GPU, just wanted to show this here. Really isn't much information here, doesn't even show the bus interface, which is definitely it's on board, right? So probably wouldn't show you. And then there's a driver version that I was using. So I did run a number of game benchmarks over that M.2 to PCIe adapter. And keep in mind that that is a PCIe 3.0 slot with a only 1x PCIe lane. So that's should limit the performance of these graphics cards, which is kind of what we're kind of looking at here. Now I did run them at 1280 by 720 or 720p resolution set to low graphic details. And so you can see the results here. On the vertical axis is the average FPS result of those respective benchmarks. And the darker settings represent the 1% low FPS of those benchmarks. I did run the GTX 1080 Ti, the AMD RX 6400, and the GTX 1050 Ti, as well as the integrated graphics on the Intel N100 CPU. So you can see here clearly the dedicated graphics card, even over the 1x PCIe lane, performed considerably better than the integrated graphics, which is to be expected. However, you do notice that even in some of these benchmarks, the RX 6400 runs better than the 1080 Ti. And the 1080 Ti is like a 250 watt TDP GPU versus like a 50 or 60 watt TDP GPU in the RX 6400 or even the 1050 Ti. But so that's kind of what's going to limit that factor is that PCIe 3.0 1x PCIe lane. So just to confirm that, I went ahead and ran these same graphics cards in a desktop in a PCIe 3.0 16x slot like you typically would in a desktop. And what you see here, and the blue is still the 1080 Ti. The darker color represents the M.2 1x slot, and then the lighter color represents the desktop PCIe 16x slot. And the blue is 1080 Ti, red is the RX 6400, green is the 1050 Ti, and then the purple is the integrated N100 iGPU. Actually, in this case, on the desktop, it was running an that should be i3 10105 CPU. And that PCIe 3.0 16x slot. So you can see the 1x to 16x improvement is pretty considerable in every case here. So you can see that that 1x slot is definitely a limiting factor in performance. However, one thing that I noticed was even in like Forza Horizon 4, GTA 5, Red Dead Redemption 2, and Shadow of the Tomb Raider, the RX 6400 still performed as good as, if not better than, the 1080 Ti. My thought is it has to do mainly because of the 720p low setting. So to confirm that, I went ahead and ran the RX 6400 and the 1080 Ti again in 3 of the benchmarks of Forza Horizon 4, Red Dead Redemption 2, and Shadow of the Tomb Raider. And then this time I ran the 720p low settings again just to confirm that there were no anomalies. But then I bumped up the resolution to 1080p using the same low settings that we ran previously. And then again, I ran it in the 1080p highest or ultra setting in each of the games respectively to see if there was any improvement. So you can see here, once I bumped up the resolution, there really was no change. But once I went to 1080p ultra, it pulled away by a decent amount, the 1080 Ti versus the RX 6400 in Forza Horizon 4. Now in Red Dead Redemption 2, again, I ran the same 720p benchmark, and then I bumped up the resolution to 1080p. You can see already the 1080 Ti pulled away significantly, then bumped up the details all the way up to the high setting, and that ran at basically double the performance of the RX 6400 in that instance. And lastly, the Shadow of the Tomb Raider did the same thing. You can see confirmed that the 720p low benchmarks were good. And then I ran the 1080p low, high resolution, same graphic details as the 720p run, and already the 1080 Ti starts to pull away. And then as soon as you bump up to the highest setting, even in the 1x slot here, it basically nearly doubled in performance, both in the 1x slot as well as in the 16x slot. So clearly the 1080 Ti is performing as it should. And it's really that 720p low setting as well as the 1x PCIe lane that's really kind of restricting performance overall. So that's it for today. I hope you learned something. And until next time, talk to you later.